Hello, everybody. So today I will present you how we have used Furhat to evaluate gaze management policy. First, I want to present me a little bit. So as I said, I'm in PhD. I recently started my second year. I'm in the CRISP team at GIPSA-lab, supervised by Gérard Barry and Frédéric Elisei. And I'm in the ATOS company too, in the InnoLab team, where they work on chatbot, virtual agent, and they have recently acquired two Furhat's head. So my subject is attention management in multi-party interaction of an embodied agent. And so today I will present you my work about robot gaze in multi-party interaction. So first, if we want to control the robot gaze in a natural way in human-robot interaction, we need to answer to two questions. Where should the robot look and how to control the kinematics of the gaze? In this presentation, I will only focus on the second question, and I will do as I have already answered to the first question. So first, gaze is the combination of head and eyes movement. But what is the coordination between these two vectors? First, we know some human characteristic of the gaze. So eyes move faster than the head. The movement of the eyes begins before the movement of the head. And if the angle to perform is small, we will only use the eyes and the head will be fixed. For the robots now, first, there are some robots that can't move their eyes independently of the head, example, the Now robot. And so in this case, the gaze is only supported by the head, but maybe it is enough. For the most advanced models that are used, they are very close to the model proposed by ET, that is the biologically inspired models on human movement, but for natural scene observation task. So it's not interaction. For this kind of task, ET found a linear correlation between head and eye movements. There are some other studies that try as us to evaluate different coordination strategy between the head and the eyes for virtual agent, but it's again the same. It's not in interaction. It's not, as you can see on the right picture, it's a virtual agent that has to look some object on a table. But for us, the gaze is to look something, but it's to communicate some intention too. For example, in human conversation, we can use gaze to impact turn taking. So we made the hypothesis that the evaluation of head and eye coordination strategies should be done in interaction. And it's our evaluation that I will present you today. So the purpose of our evaluation is to test the importance of the dissociation of head and eyes movement, or maybe it's enough to just use head movement as for the Now robot. The original method that we have used is to take the Furhat robot and replay a recorded human behavior in interaction, so resynthesize the speech and the gaze, but with different head and eyes coordination. We choose 4 different policies. The first policies that take into account both, so eyes and head, that is the closest to the human behavior, is the eyes-head policy, where the head movement will be exactly the same than a recorded human. The eyes-only policy is the same. The robots look at the same target, but it will only use eyes to perform the movement, and the head will be fixed. For the head only, at contrary, the head performs all the movement, and the eyes will be fixed, as for the Now robot, for example. The last condition is the Furhat policy that is already built in Furhat. This policy takes into account some human characteristic of the gaze. So the eyes move faster, the eyes movement begins before the head movement. But the specificity is that at the end of the movement, the head will follow the eyes, and the head and the eyes will be aligned in the gaze direction. So we made the hypothesis that the behavior of the robot in eyes-head policy will be perceived more natural than the three other, because it's the closest than the human behavior. So I say that we want to replay a recorded human behavior, but which human? So for that, we have the ROBOTRIO dataset, that is a collaborative game between 2 humans and an animator robot, the iCube robot. So the purpose of the game is that the two player has to find what are the most quoted words according to a theme. So it's a French corpus. So for example, the theme can be essay, try in English, and the different answer can be test or rugby, for example. The specificity of this dataset is that our robot is teleoperated by a human pilot, as you can see on the left. So the human pilot is wearing a virtual headset, and he can take possession of the robot's body. And through the robot's body, he can interact with the two human players. So the robot will reproduce exactly the same movement than the human and transmit his voice. And thanks to this setup, the humans player are thinking that they are interacting with a robot with a human-like behavior. But for us, we can record human data and already take into account potential difference that can exist between human conversation and human-robot conversation. Okay, so just a small video to show you the ROBOTRIO interaction. So in the middle, you can see the iCube robot teleoperated that reproduce all the movement of the pilot. And on the left and right screen, it's what the pilot is viewing. And so the cross is where the pilot is gazing at any moment. So now he's gazing the left subject, maybe ask for a proposition, the right subject, and then you can check the answer on the tablet to see if the answer is correct or not. Okay, so now we have the human data, but how we play a human behavior on Furhat? So first I will show you that, yes, we are able to do that, and we are able to do that on the iCube robot and the Furhat robot. So in this video, you will see that the two robots reproduce exactly the same thing.
Est-ce que Sylvain, tu as une idée pour Kermesse?
École.
Est-ce que ça te semble une bonne idée, Christian? Alors école, c'est effectivement le deuxième meilleur mot. Une autre idée?
Okay, so how we do that? So we made the hypothesis that in all the policy, the robot has to look at the same gaze targets. So we have three gaze targets: the user left, the user right, and the tablet, where the pilot can see the different informations about the game. So we create three fake targets with the different position, the same position than during the ROBOTRIO interactions. And so we are sure that the robot will look exactly the same target, because we will say to Furhat to look at the fake target tablet or the fake target user right. Okay, so we have the fake target, but now what we have implemented, how we have implemented the different gaze mode for each policy. So first, for the Furhat policy, we just use the Furhat attend function, and we give the location that we want. So for example, here it's the user left location. For the eyes only policy, it's almost the same, but we use the gaze mode function to precise that we want that Furhat only use his eyes, sorry, for the gaze. And for the head only and eyes head policy, it's almost the same. We create an event, we give the location, so one of the three fake targets, and we give the head pose, so the pitch, roll, and yaw angles. If it's the eyes head policy, it's exactly the same angles that have been performed by the pilot. And if it's the head only conditions, it's just the sum of the head and eyes angles performed by the pilot, and that's all. Okay, so just sorry. In this slide, I want to say thank you to the Furhat team, because they implemented this gaze mode function, and it's very easy, as you can see, to switch between these different policy. And a small video to show you the different policies. I'm already sorry, because maybe with the Zoom stream, the desynchronization of the robot will appear, but the robot will look exactly the same target, but with different coordination.
Est-ce que
I'm sorry for the...
Sylvain, tu as une idée pour kermesse?
École.
Est-ce que ça te semble une bonne idée, Christian? Alors école, c'est effectivement le deuxième meilleur mot. Une autre idée? Christian propose fête, ça te
Ouais, ça me
semble
semble bien.
bien? Alors on valide fête. C'est le meilleur mot.
Okay,
Bravo.
so now we have our different policies. So how we can evaluate these policies? So we select 15 small clips of interaction in the ROBOTRIO corpus, multiply by the 4 policies. Each clip it's around 10 seconds. And we conduct an MVIP Mushra-like comparative evaluation online, where the subject watch all these 15 clips video, multiplied by the 4 policies, and they have to rate each videos in function of if they think that the robot's behavior is natural or not. Just to precise, the subject it's in the middle, is facing the robot, and he has the sound in stereo to understand the context and to know who is talking or not at each moment. In total, we have 50 subjects that pass the experiment. Just a small, it's just to show you one of the web page. So it's inspired of the MVIP test. So we have 4 buttons. Each button run an extract. It's the same extract of interaction, but for one of the 4 policy. The order of the policy are shuffled, and you can see the 4 scales to give a grade for each videos. So the result that we obtain, clearly we can see that the eyes-head condition obtained the high test score. In the second, it's the head-only policy, but with a smallest difference. And surprisingly, the Furhat policy that take into account head and eyes movement didn't obtain a really good result, but maybe it's just due of our interaction context because we are in multi-party. Okay, so to conclude, I think our method is very original because we use teleoperation to collect human data already in human-robot interaction. We use this human data to replay a human behavior and evaluate different coordination strategies in interaction context. And our results show that if we want a gaze as natural as possible, we need to use the head and the eyes movement. But just control this both is not enough. They need to be controlled in a subtle way, maybe taking more the context into account. So hopefully, maybe you will be able to read more about our experiment on HCI International Conference. And for our future work, we want to use machine learning on this data to generate an attention model, 2 outputs for this model, one for where the robot has to look, and one for which angles, head angles it needs to perform. And we want in the input of this model to take into account the context and the conversational regimes of the interaction. And for example, I didn't present this today, but we see that the human pilot move his head in a different way if he is talking to one or both players. So for example, it can be one of the input that we can use in our future models. So thank you for your attention, and thanks again to the Furhat team by inviting me today.